Good morning, everyone. I'm Giacomo Porcarelli, a master's student at the University of Padova and member of the J2050 team. With the J2050 team, we are developing the Redpill mission, and we are here to present Redpill innovation and miniaturization in a student PocketQube project. So, starting from the basics, we are a student team based in the University of Padova with a multidisciplinary scope that aims to gain a real hands-on experience on space projects, thus enabling them to develop hard and soft skills. We started our journey in October 2023 with just 12 students, and we participate in the Flyer Satellite 4 call with the PocketQube. We got selected and expanded our team to 37 students as for today, but not only our size increased, but also our academic experience, because the master students were 2 at the beginning and now are 16. But what's the Redpill mission? The Redpill mission is a 2P PocketQube with both scientific and educational goals. For what concerns the scientific goals, we have 3 payloads to bring to orbit that are clear, clouds, and crystals. Clear is a payload for attitude recognition and reconstruction. Cloud is a payload to validate the sub-millimeter debris environment in low Earth orbits. And crystals aims to be a non-mechanical cover for space telescopes. For what concerns the educational goals, we want our students to develop hard skills such as the ability to develop and test space-ready technologies, soft skills such as teamwork, public speaking, and so on, but also, as for the, let's say, the higher educational goal, to develop a PocketQube platform that can enable an easier access to space for all university and students around the world. But what was our timeline? So, as I said, we created our team in October 2023 and started our journey, and then we participated to the ESA Flyer Satellite 4 call. We were selected for the selection workshop that was in February 2024, sorry for the little mistake there, and after we got selected inside the program, so we had the good news to take in account for the greater workload. We did our first round of recruitment in March 2024, and then we built it up towards the training week that we did with ESA at ESEC in April 2024. After the training week, where we learned some insightful experience on environmental testing, we had to prepare our documentation for the kickoff review, so building to first CDR of our project in October 2024, and after that we did our second round and for now last round of recruitment. Now we're really building towards the post-kickoff review that should be the final design iteration of our PocketQube to start with the system level testing and then environmental testing. But what is the current design now? So this is the exploded view of our Redpill satellite. For their, let's say, main feature, we have a power subsystem composed by a 2S2P battery pack with a 12 watt-hours energy storage. We have an active OCS based on magnetometers. OBC and all the electronics are developed in-house based on STM32 microcontrollers technologies. And the structure is a PCB stack with M3 stand-ups to make it sturdy enough to sustain launch. But the design was not always like this. In fact, thanks to the Flyer Satellite program, we had some suggestions and ideas by ESA experts. And so here you can see a bit of our satellite development. The first one was the satellite that we proposed at the Flyer Satellite Proposal and Selection Workshop in January 2024. And the last one is the today iteration of the design of the PocketQube. As you can see here, a lot has changed. For example, we switched from a passive attitude system to an active attitude system from the first to the second one. That was a requirement from the Flyer Satellite program. We also changed the EPS design to a 2S2P battery pack instead of 1S5P battery pack in the first 2 designs. Another thing that comes to the eye easily is the antenna design. We had to change it to the last iteration where the antenna is positioned to the back of the satellite to enable a safer deployment and also a more reliable deployment. All this iteration let the student gains, as I said, real hands-on experience on the project. Almost every day there are students working in our laboratory to develop the satellites. We also did an environmental SM campaign on July where the students understood how a proper environmental campaign has to be conducted for a space project. And also thanks to ESA, we had the opportunity to go to ESEC for the training week to understand better what a space project is. Switching back to the payloads of our mission and understand them better, we have crystals. That is a non-mechanical space cover for telescopes. It is composed by an electrochemical system made of one electrode and two counter-electrodes. It works that when the energy flows inside the electrolyte system, the ITO glasses darkness and protects the optical from unwanted radiation and solar exposure. Thus enabling to have a more reliable system than the usual mechanical covers. The second one is clear, that is a compact attitude reconstruction made of LEDs. As you can see here, there are some simulation of our attitude system and reconstruction made in Simulink. Essentially, we want to increase the accuracy and precision of tracking of objects in LEO using our new using this payload. And the last payload is our cloud payload that is classifying orbital undetectable debris. As I said, it's a payload that wants to carry out in-situ measurements to validate the debris environments of sub-millimeter environments debris in LEO. This is a payload that has a strong heritage inside our university because it was firstly developed by our professors and then also developed by another student team that is Alba CubeSat, that is also in the Fly Your Satellite Design Booster program. We scale it back and miniaturize it to be able to fit inside our Bluepill PocketQube mission and be able to test its performance in orbit. So for our accomplishment and looking ahead, we had some achievements that were being selected inside the Fly Your Satellite program. We did some vibrational testing on our SM model of the satellite to validate our structural simulations. We expanded the team, and now we want to conduct a further functional testing on our platform at system level and be able to conduct a proper qualification test campaign in November 2025, hopefully. We want also to enlarge our scope and bring Redpill to schools in order to engage also high school and middle school students and so fulfill our long-term goals to learn and spread the knowledge and the space knowledge. Thank you very much for your attention, and thank you to ESA Academy for sponsoring me and be here today. Thank you very much.